Hi, this is Justin, and I want to do an overview of the decentralized cloud as part of the Decilium protocol. This is a third part in the series of the layers of the Decilium protocol, sitting on top of the general realization that users bring their own computers. So we should find a way to allow users to solve as many security and network problems as they can locally and run as much of the application as they can locally in cooperation with each other instead of putting so much pressure on AWS and Google Cloud. So as mentioned, we previously covered the proof layer, the transfer layer. The decentralized cloud layer provides a lot more high level services that developers and businesses are used to, such as things like cloud functions, virtual pool of memory, being able to search all the registered computers, being able to run virtual processes, acquire semi permanent storage or redundant storage, and even run Docker containers. So this is something that the Decilium Cloud orchestrates on top of a user network on behalf of application and network administrators. So, as a simple example, but also an interesting example when considering um, network development, we'll talk about a payment server example, something like a Stripe payment form. Somewhere where someone might be able to submit a payment for something like buying a T-shirt. First, we'll discuss the status quo. The status quo kind of looks like a developer sets up a web app and a web server and a payment processor that connects to Stripe. They upload the web app, the payment app, which is going to be a more secure, smaller app with any secrets or keys to cloud services. And they set up all the permissions and everything, and then they have to manage those corporate assets. When a payment comes in, the payment description flows in with any special keys or information that have to accompany the payment. And then all that information can be sent off to the payment processor. In this case, we're showing Stripe. The attack surface can be quite large and does include a developer themselves. So obviously, we know that this solution is, although convenient, you can deal with cloud hacking and you can deal with key leakage, back end code leaking, all kinds of issues here related to these cloud services. So we're going to talk about, not to mention, sorry, I want to mention also having the legal responsibility to the government and to other parties about the kinds of payments that are being processed and why, right? You might have a legal responsibility if this stuff is custodied by the corporation. So let's talk about another example. Similar to the transfer layer, a developer can publish the app into the population of actual users. So the users of the platform can also be people running the web application that accepts the t-shirt payment. Now, what we do here that's a bit different is we do have a trusted user, potentially a founder or a developer, or maybe it could be somebody from a third party payment processor that might not be affiliated with the corporation. Whoever you want can run a small app. We have some examples where all they really do is store the payment key and they have a Stripe account, let's say in this example. And then what happens is this individual, or if it's a corporate account, this corporation is the one in charge of the fiat transfers or payments that are happening on the network, right? Now on the user side, they're going to use the web app, visit one of these other computers as was covered in the transfer example, and they will receive some sort of payment details, and they'll probably generate a payment secret. There's a bit of a difference here when dealing with a decentralized network. You don't want to send this payment secret through a public network because it could, depending on the kind of secret, it may or may not compromise the individual user. So that payment secret is usually sent directly to the trusted user, and it's usually a small amount of data that has to accompany a payment description. Now, the payment description can be modified and uploaded and generated by the web app. So this web app actually takes the payment description, does some preparation, and this usually the user visits the website, fills out a form, and the payment description materializes and then gets sent as usually JSON to the actual trusted user device. So now this trusted user has a payment secret and the payment description and the key, and that little application that's running on that trusted user's device, usually a little phone, but sometimes a little laptop sitting in someone's office, process the payment and returns proof of payment to the web app. Now we can rely on the propagator on the transfer layer to propagate that payment history back to the original user, giving them a pop-up like your payment's been processed, here's your proof, and that payment history can also spread through the network as a form of within a decentralized ledger. So this kind of sets up a complete, other than this one trusted user in the corner, who is tied to Fiat, who has to manage keys. Every other part of this network is not corporate. It's actually users running their own payment network. And this actually simplifies significantly the pressures of an audit. So an audit pressure here just has to audit the trusted user device. That's it, right? You don't have to worry about the web app in terms of security. Furthermore, if everything in the web app is reasonably insecure, it never puts any user or their payments at risk. So you don't have a weird situation where you have a very complicated cloud service set up and you have to worry about, well, how did that key get leaked? I thought it was, or blah, 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 blah. It's actually a very simple app that sits on one device, maybe you have three of these devices, geographically decentralized. So maybe one of your admin business team is in China, the other one's in, somewhere in Singapore, and the other one's in, I don't know, Chicago. And these three people run this one app with independent keys on their independent Stripe accounts, and you have complete lockdown of what payments were processed, why, and where. And it's very easy to audit and keep things secure this way. Very easy to shut this down if something goes wrong as well. So that's the general workflow for processing payments on a decentralized network, and making sure that in general you take advantage of the resiliency of your clients and the fact that they're bringing their own devices. So that was a quick overview, or one quick example of one of the features, namely the cloud functions. But there's also, cloud memory, search, processes, storage, and containers as well that I didn't have time to go over. But yeah, I'd be excited to chat about more. And if you have any other questions, let me know.